Hey everyone, today we're going to talk about a very interesting topic, cost management, and how we do that in Airflow. So my name is Olivier, I'm a staff architect at Astronomer. I'm part of the customer office team, so my job is essentially to help customers be successful. I mainly work on three things: migration projects from any schedulers onto Airflow. I work on AI and ML operationalization as well, and I help customers with cost and performance optimization. And so for today, the agenda is pretty simple. I sat down with the data team at Astronomer about 6 months ago because we had a small problem that I believe everyone here might have had in the past. And it's super simple. Our Snowflake cost was ballooning. And we didn't know what job needed refactoring first. We didn't know what users were running queries that had issues. And basically, we were looking for ways to automate solutions for that. Today we're going to talk about that cost management problem, how we can attribute Snowflake costs to DAGs and tasks in Airflow, and how we can detect abnormal usage in our different Snowflake warehouses. I'll also introduce a Snow Patrol project that we've built to solve that, and how you can use that today. And finally, I'll show some outcomes, some dashboards that we've built for the team to help track things. So just to get some intro, Data Astronomer, if you were here yesterday, you might have seen a nice talk by my colleague Maggie and Marian. They introduced how they do data at Astronomer. Essentially, we have a central data team that assists all the different business units, and they cover multiple use cases, such as the Astro embedded dashboards. If you're a user, you might have seen this. We do usage analytics on all the operators and everything Airflow related in Astro. They do sales reporting, they do customer 360, and so on and so forth. And self-service is really core to our culture. And so we have many users running different queries manually or automatically in their own DAGs in our environment. And so everyone is encouraged to answer their own questions, and we end up with hundreds of users running queries at each time. If my memory serves me right, we're about 800,000 queries a month running on our Snowflake instances. So just to give you a sense of size. And so the cost management problem is really simple. We don't want to be paying for inefficient process, and we just want to keep costs down as much as we can. And so you can see here how the different costs in our Snowflake instances spiked over the last few months. And obviously, we had to go in there and figure out what happened for those specific spikes that you see here, right? And this is the whole concept of the project. So really two key things to solve for. The first one, attributing Snowflake costs back to specific DAGs and tasks. And the second one is to catch unexpected spendings as quickly as we can. Let's say a user runs a query without the right join, or forgets a where clause or a limit clause, and the query runs for hours. We want to be catching that and teaching them how to write the queries better. And so we need to be able to catch those queries as they happen, right? And so for the first one, attributing Snowflake costs back to tags and tasks, there's different ways to go about this. The manual way would be to go into the Snowflake usage query history table, and then you would try to kind of find the needle in the haystack there. It can be done. It's a bit time consuming. The automated way that, if you're familiar with query tagging, that's basically the recommended approach. And so if you were to do the manual approach, you would go into the Snowflake tables, you would look at the query history, current usage and currency daily tables, and the rate sheet daily tables, and you would combine those three tables into a query to figure out how much you're spending for different things in Snowflake. And you would end up with a query that looks something like this, where you would filter on the warehouse on the execution date, and then you would find out which query we're running at that point in time and how much you've been spending on those. You also get in the metadata tables the number of rows updated, inserted, and so on and so forth. So you get a nice overview of everything that's going on in there. If you are to automate this with Airflow, you could do something like this, where you would have your DAG definition, and then in your SQL step there, you would have an alter session statement to set query tags. And with the Jinja templating, you would be adding DAG ID, task ID, and all of that in there. And if you're familiar with altering session statements in Snowflake, you really have to do two statements in the same query. And so you would have to do that manually for every single task that you have in your DAGs. So obviously, if you look at this for 2 minutes, you'll realize it doesn't really scale well, and it's a lot of manual labor involved. And so there is a better way to do this. And it's something that I looked at a few months ago back in April. There's a PR that I opened in the open source Airflow project to basically enable query tag at the session level. And if you do it that way, the big benefit of doing that is now it's being done at the hook level, And so it can apply to every single operator that uses that hook. So in this case here, we're using the SQL execute query operator, but since it's changing, it's affecting the Snowflake hook behind the scenes, it would work for every single other Snowflake-related operators or sensors, and you get pretty much everything for free with this approach. The good news also with that PR is it also applies to many different databases. For example, BigQuery does it in a similar way. SQL Server does it in a similar way, Oracle, and so on and so forth. So we get to kill multiple birds with one stone. And for those who are not familiar with the specific syntax of template fields, you do have to hack a little bit, and you can see it at the bottom, hack the template fields so that the Jinja templates render correctly. But yeah, so this is also something that's been fixed in the Airflow versions there. But yeah, so this essentially gives you everything that you need there. And so with that, what you can then do is in the same query history table, you have a column for query tags, and you can then parse the JSON and look at all the Airflow metadata in the same query. And so you would do something like this, where you get your query ID, you get the query text, and then you would parse the JSON query tag field for the DAG ID, task ID, and all the Airflow related metadata. And so with that and the query that we looked at before, you can then have a pretty good sense of exactly which Airflow DAG ran which query and how much you've spent on that. And so this gives you the number of rows directly in the Airflow, in the Snowflake metadata, the number of rows that were updated, inserted, and everything that we've seen before, plus the Airflow metadata, all in the same thing. So yeah, that's the automated way of doing this. And then the output looks something like this, where you have the same columns with the details, and you can see the Airflow DAG ID, task ID, run ID, logical date, and all of that. Query text, and obviously I had to truncate the table because it would be going all the way over here, but you get all the metadata as well. So yeah, that's been pretty life-changing for us over the last few months. Now, for the second problem that we have is catching unexpected spendings. This is what our warehouse costs would look like a year ago from now. And you can clearly see that at warehouse level, the consumption is very spiky in a way. And so we really wanted to be able to figure out what caused those spikes and what queries were run at different levels there so that we could basically go in there and figure out what the query was, if it was a DAG or a human that would run it, and then get involved to solve it. And so what we settled on doing is a simple anomaly detection model to basically detect those spikes, and then we could then, with that, send alerts. And so if you're familiar with ML models, we're using scikit-learn here with an isolation forest. And yeah, with that in mind, we can then basically do time series decomposition to remove trending, to remove seasonality and all that. And then we can do an isolation forest to identify outliers. And then with that, we can then send alerts. So this allows us on a daily basis to figure out if there's anything that runs during the day that would increase significantly our spending. And so we could catch that and address it with the user. And so with all of that combined together, we're able to detect those anomalies and then send alerts based on that. So all the black dots that you see here are the data points that our model identified. And so we train the model frequently, on a weekly basis, and then we use that to predict every day. And that way we can catch any abnormal usage, and then we can send alerts. All of that we've packaged into Airflow DAGs for our own use. And so it makes things much easier for us to track our Snowflake abnormal patterns there. And so if we put everything together, basically we wanted to be able to bring this solution that we built in the house to our customers and to any Airflow user. And so what we did is we put everything into one solution that's called Snow Patrol. And Snow Patrol is essentially two things. It's two Git projects combined in one. It's an application to monitor Snowflake costs and detect abnormal usage. Two Git projects that are working hand in hand. The first one, Snow Patrol, is the one for all the reporting and anomaly detection. And so we packaged in this repo everything related to data prep for everything that we saw before. So all the data crunching for Snowflake cost analysis and all that, and so that you can have a single table with all the details, just like I showed before. The second one is the Snow Patrol plugin. This is for automatic query tagging. This one you need to deploy in every single one of your Airflow deployment for it to work. whereas the first one, it's a set of DAGs that you can deploy only once, and you get results in Snowflake. And the way we do this is pretty simple. We have a few create table scripts in that project that you can use, and then you can hook your dashboards on there. And so, yeah, if you want to look into the Git repo, QR code is here, and I'll go into details on how we actually built that plugin. And yeah, as I said, this needs to be installed in every Airflow deployment, and you can simply do pip install the plugin name there, or if you're on Astro, you add that to your requirements.txt. And the way it works, for those of you that were here last year, my colleague Phil did a great talk on Airflow cluster policies. For those who don't know, cluster policies are a way in Airflow to essentially intercept different activities in your Airflow deployment and then inject some behavior. And this is what we do here, where we intercept every SQL query sent to Snowflake, and then we add the query tags, just like we've shown before. And so this is essentially the core of the plugin. You can see the query tags that we looked at before, session parameters the same way we did before, and then the task policy at the bottom. And so every single time a task is being run in any of the DAGs in the whole deployment, this intercepts it, adds the query tags, and then every time the Snowflake hook is being invoked, we add the query tags automatically. And so you don't have to go into every single SQL tasks and change things. And so, yeah, the second repo, Snow Patrol, you can look it up here. And the idea of this is, as I said before, all the anomaly detection DAGs that I showed before, plus all the reporting for all the Snowflake cost analysis in the same thing here. And so if we go into the details here, you can see all the different DAGs that you get. There's an initial setup DAG here. So this one, once you configure the right connection to Snowflake with the right level of permissions, this one creates all the tables and the views that you need for the dashboards that I'm going to show in a minute. And then you have data ingestion. So the three tables I mentioned before, the query history table, the usage and currency table, and the rate table. We do data prep for the model, and then data reporting to prep some tables and views for dashboards. As it is today, we don't give the dashboards directly in here. It's something that I'm working on, but with all the tables that are there, it's pretty much a plug and play for any reporting tool as it stands. Thanks to my colleague Tamara, we have this awesome illustration of everything that's going on in those DAGs. So you can see here on the left, metering history view, metering history table, all the different Airflow steps at the top there with the DAGs that I just showed before. And then you get all the steps for the model training and the prediction model there at the bottom. For simplicity, we're using weights and biases to store a model. That's not necessary. You could do without if you wanted. It was just a plug-and-play solution for us to move on quickly with this. And then once we detect anomalies, we are able to send Slack notifications. And it would be also pretty much plug-and-play and just replacing that with email notifications if we wanted. And as I said, we feed in reporting tables so that we can then provide dashboards. And so here is what dashboards we can get with everything. So we have 4 different sets of dashboards here: anomalies, DAG costs, storage cost, and warehouse cost. And then here's what we get. We have filters for the different parameters we can find here, the different DAGs, the time range, and all that. And then we do that for all of our DAGs, and then we get nice dashboards to explore the different costs. And so the first one is at the DAG level, and we get the information for every DAG here. We can see the trends and all that. The second one is at the task level. We can see trends, and then we can then explore and figure out if there's anything that needs fixing. Here is the detail for every single run, so the total execution count, the credit costs, and how much it costs on average to run. So with that information, we're able to prioritize our different initiatives internally. And then we have the details with all the query level information. And so we have the cost for every single query that is run, when the information of the tag that's related to it, and all of that there. Then we have warehouse cost. This gives us, at the warehouse level, information about the different services that we're paying for, and then we can then explore the metrics there as well. And then with that, we can detect spikes as well, maybe more manually than with the anomaly detection, but still it's pretty useful to have. And then we can track the spendings, the credit spendings for different warehouses. And we also add deltas so that we can see on a day-to-day basis if there's any big changes from yesterday to today, we can see it quickly here. The final one is Snowflake anomalies. And so this is the output of the model that I just talked about. And this one at the warehouse level again, you can see some of the spikes here. And then for each of those, we have details here at the bottom of exactly what happened at that time. So on which warehouse, which date is involved, the score tied to that anomaly, and then how much we spent on that. And then we can then break that down into, is it Airflow that caused it, or is it any users that caused it? And as you can see here, I'm the biggest culprit there, with a bunch of queries that I ran back in June that would cause any anomalies there. But yeah, with everything in here, it's much easier for us to track any unexpected consumption at the Snowflake level. So the outcome is a plug-and-play solution to automate all the manual analysis that we used to do before. It allows us to explore the costs for the different services at the DAG task level and any granularity that we want, really, and then receive alerts if there's any abnormal usage in any of the warehouses. So our team can focus on what's really important, helping our business users and building new dashboards for reporting. And so with that, we can then have the PM teams and the Scrum teams and all that prioritize the refactoring wordlessly. And then it gives us a much better view of what's going on. Conclusion here, what we've built here is a one-stop shop for cost management. We are looking to expand this to other cloud platforms. Obviously, Snowflake is not the only one. We're looking to do, as I said before, BigQuery, dbt, Databricks, SQL Server, Oracle, and others. So yeah, come talk afterwards. I'd be really interested to learn what you have to say about that. So feel free to download it, give it a try. Let me know how it goes.